Hello students, I am Dr. Chamuna. Today in this session, I am going to speak for B.Sc first sem general chemistry paper with the topic Purification of Compounds by Fractional Distillation and Distillation under Reduced Pressure. Already we have discussed about distillation and steam distillation. Let us go in detail about fractional distillation. What is the principle behind this? Here the process is used to separate a mixture of two or more miscible liquids. Those have boiling points very close to each other. Means in the simple distillation we saw separation of two liquids based on their differing in their boiling point. Here no doubt they are differing in their boiling points, but boiling points are very close to each other. So we carry out this process by using fractionating columns. So let us see what is this fractionating column. It's a special type of long glass tube. So it has abstractions to the passage of the vapor upwards and that of liquid downwards. You can see here. These are the different fractionating columns. It has some abstractions you can see here. This and this has a little bit less, but if you see these two tubes has more obstacles. So this method can separate a mixture of acetone and methyl alcohol where they define their boiling point. You can see here it is 330 Kelvin and here it is 338 Kelvin. They differ only by 8 Kelvin. Or even a mixture of benzene and toluene, they differ very less in their boiling point. Such mixture of liquids can be separated by fractional distillation. This is the setup for fractional distillation. You can see here round bottom flask fitted with fractionating column. Both are fixed to the stand, right? At the bottom you can see the Bunsen burner, and this has a long side tube to which condenser is fixed. In turn, condenser is fixed to the receiver or flask where both are connected through the adapter or bent tube. Again, this receiver is also fixed here. Condenser is fixed. It has two outlets, one for water inlet and another one is for water outlet. So water can be connected through the tube and it is made to circulate through the condenser. When the highly volatile liquid enters here, it condenses and it falls here. So this is the fractionating column. You can use any type of fractionating column depending upon the mixture of liquids what you have taken here. So here you can see the thermometer is fixed. Sometimes if Bunsen burner is not sufficient, you can use even this oil bath. So already I have discussed about the different types of fractionating columns. Now let us pass on to another method of distillation, that is distillation under reduced pressure. Here the principle is certain compounds present in the liquid, that is solvents, they are decomposed very much below their boiling point and they cannot be purified by distillation. So in that case, what we do is we employ this distillation under reduced pressure. So let us see in detail what exactly this. The boiling point of a solvent is dependent on the atmospheric pressure. We know very well. I have discussed already in the previous video. The liquids will boil at a temperature lesser than their boiling point when they were distilled in an atmosphere having lower pressure. You can decrease the atmospheric pressure. When atmospheric pressure is decreased, then the liquid starts boiling very much below its boiling point. So this can be achieved by vacuum pump. If you attach vacuum pump, it will decrease the atmospheric pressure. We know very well the boiling point, it is the temperature at which the liquid boils when its vapor pressure and the atmospheric pressure equals, then only it starts boiling. That temperature we call it as boiling point. But when you decrease the atmospheric pressure by using vacuum pump, even the liquid boils very much below its boiling point. As a result, the compound will not degrade or decompose. So here the liquids also boil faster, and the whole process of distillation is made very fast. You can see the distillation under reduced pressure. This is the setup. You can see the round bottom flask, little more different here. It has long side arm here, and here it is fitted with a capillary tube to regulate the air, because we are employing here vacuum pump, right? And to this side arm it is connected with the condenser, and condenser is directly connected to the receiver where distilled liquid we get. Again, it is with the little different here. It is not the flask. Here it is round bottom flask with the side arm where vacuum is created. And again, here it is condenser. It has two outlets. One is water outlet, and here it is water inlet. So liquid, that is tap water, is made to run through the condenser. As a result, the highly volatile liquid, when it enters the condenser, it condenses and it falls. So here we carry out distillation under reduced pressure. That is, atmospheric pressure is reduced by using vacuum pump. As a result, the liquid starts boiling very much below its boiling point. As a result, the compound present here is, it will not degrade. So these are the references I made. So you can go through any organic textbooks, you will get the information about this. This is Digital Learning, Department of Collegiate Education is presenting for you. Thank you very much.